What's up, Glenwood? Mr. Wiedeman here. This is mass-to-mass problems, or gram-to-gram problems. Now, pay very close attention. This is the most complicated of all the things that you've done so far, so if you watch the previous videos, you need to do those first before you even ever try to attempt one of these. You need to be able to do molar mass, mass to mole, mole to gram, and mole to mole questions. So basically the last few videos before this one. That's the key. So let's go ahead and start. I'm going to take a look. If you're looking at MrWiedeman.com, Chapter 7 materials on the top, you have the flow chart again. We're examining this part of it. If you are going to start in mass of one substance, you can go completely to mass of another substance. So let's call this substance A in grams. Right now, when you're down here, you are in grams of substance A. In order to move all the way over into grams of substance B, well, you have to hit all these steps along the way. So you first have to have the molar mass of substance A to get here. Once you're here, you're going to do the mole to mole step to go from A to B. That's called the mole ratio, and that's how, you learn how to do this step in the mole to mole video. You learn how to do this step in the mass to mole, mole to mass video. So basically you're going to go from here to here to here to here. So there is going to be a start box and 1, 2, 3 steps every single time. So watch what I'm going to do. If you're following along with me, you're going to be doing the mass to mass problems worksheet that looks like this off of my website, and I'm going to be working with question number 1. So here's how you figure out how you start these problems. Mole to gram, how many grams of potassium chloride are produced if 25 grams of potassium chlorate decompose? Well, here's how you figure out what you start in. Here's a number, here's a unit, here's a substance. That is what you're starting in. And just to kind of help you out here, here's what these compounds actually are. Potassium chloride is KCl. Potassium chlorate is KClO3. If you do not know how to make these compounds or name them, you're fully responsible for doing that come test day, and you're going to watch the Making Compounds video, which will be posted sometime soon. So you're starting in 25 grams of potassium chlorate. So here's what your start box looks like. So this is 25 grams of KClO3. And again, I'm labeling that my start. So that's what your start looks like. If you're going back to your flow chart, that's where I am right now. I am starting right down here in what I'm calling substance A. Well, in order to go from here to here, you hit these things along the way. This, this, this. So the first thing that we hit is the molar mass of substance A to go from grams of substance A to moles of substance A. So basically, we need to find the molar mass, and then molar mass is going to be our next step, and the work is going to look very similar to this. Therefore, I already know this next step is called the molar mass. Molar mass of this compound. So what I'm going to do, flip this over if you're following me. We're going to have to eventually find this one, but for now, let's focus on this guy. We need to find the molar mass of this guy here. List out the elements that are in the compound. K, Cl, and O. How many elements of each do you have in that compound? You have 1 K, 1 Cl, 3 O's. Now we need a periodic table to find them on the periodic table and round them to the hundreds place. So K on the periodic table right here is going to round to 30. We'll see, this is 39.098. That 8's going to round the 9 up. That 9 is going to round this to 10. Okay, so the 8 causes the 9 to go to a 10, so that's 39.1. 39.1 or 39.10 times by 1, 39.10. Chlorine on the periodic table rounded to the hundreds place, 35.45 equals, times by itself, the same thing. Oxygen, I've always told you, always, always, always in this class. Where is it? There it is. 15.99999 always rounds to 16. And because I'm terrible at math, quick calculation, 16 times 3 is 48. Add them all together. So that is 39.1 plus 35.45 plus 48 gives me 122.55 grams per mole. So I needed to find that before I even begin. And why did I know that? Because of the flow chart. To go from substance A, grams of substance A, to mole of substance A, you hit the molar mass of substance A. So now we're going to use this number just like we did in my previous videos. So using this number now, you do not want to be in grams of KClO3. Therefore, you want to cancel it in the universal spot, put it down here. KClO3, mole of KClO3 on top. And I'm going to need more boxes, so that's just for the future here. So right now I have mole and gram. On the molar mass step, just like we've showed you, and using this guy, 1 is always going to go with mole, and the number in gram is always going to go with the molar mass on the bottom. So 1 always goes with mole in the molar mass step, and the number in grams comes from where you calculated this earlier. The number always sticks with gram. In this case, that is 122.55. I'm copying over here. 122.55. So that step is going to take me here. Now I can do the mole ratio step, hopping from one substance to another using a balanced chemical equation, and that's called the mole ratio step. If you don't know how to do this step, you need to watch the other video called mole to mole before you do this problem. So now since I'm in moles of A, I can go to moles of B using a balanced chemical equation. And that's what this step is called. So this is the ratio step. You do not want to be in mole of KClO3. You want to be in mole of what compound? Reread the question. How many grams of this? That's what you want to be in. Now you use the coefficients in front of the balanced chemical equation. Okay, that's right up here. What is in front of KClO3? KClO3, it looks like there's a 2 in front of there, so a 2 goes there. What's in front of KCl? KCl, there's a 2. 2 goes there. So now, you just did this. You hopped from one substance to another when you were in moles using a balanced chemical equation. The last step that you need to do to get back to grams of substance B is you hit this. This is your final step. You need the molar mass of substance B. So, I know I'm running out of room here. My last step, molar mass. And I need to find the molar mass of this last substance that I'm going to be in, which I am now, okay? Because this is the way this works. It moves diagonally this way and changes. So right now I'm in KCl. Now I need to find the molar mass of this, which I said I would earlier because you saw it here on this paper. So this is the molar mass of the other substance. We're good. Now we're going to find the molar mass of this guy, K and Cl. In this compound, I have 1 of each element. I need to find them on the periodic table and round them to the hundreds place. So in this case, K is 39.1 or 39.10, like I told you earlier. Okay, I'm just going to leave it there because anything times 1, I'm running out of room here. Already making a mess on my desk. Chlorine is 35.45. Just double check it. Yep. I'm going to add those two together. I don't need to times them by 1 because obviously it's just going to be the same thing. So 39.1 plus 35.45 gives me 74.55 grams per mole. How did I know how to do this? Well, probably because I watched the molar mass video from this same website. Okay, so that's the molar mass of KCl. So now you're going to use that for the last box. You do not want to be in mole of KCl, so you're going to cancel it by putting it down here. You want to be in grams of KCl. Now, the molar mass box from the flowchart thingy, you obviously see the molar mass is going to be on top and 1 mole is going to be on bottom. Doesn't that look the same? Exact same. So therefore, I told you that 1 always goes with mole in the molar mass step. And this number, 1 always goes with mole, the number goes with gram. 74.55 grams. Now here's how you finish all this work, because this is going to be kind of a doozy putting it into the calculator. So I'm going to do separate work right here on a piece of paper just to kind of show you what all these numbers are. What I'm going to do is I'm going to multiply everything on top together first, in parentheses, in my calculator. Then I'm going to hit the division sign and multiply it by everything on bottom, then equals sign. So here's what my work looks like. 25 times 1 times 2 times this. 25 times 1 times 2 times 74.55. Close. Division sign, because you're dividing by what's on the bottom. Open parenthesis for the bottom. 122.55 times 2 times 1. Close. This times this times this. Now, you could just get rid of this and do a division sign this way. As long as you know what you're doing, doesn't matter. Basically, you're taking the top multiplied together, divided by the things on the bottom. So here's what you're going to do in your calculator, button for button. Open parenthesis. 25 times 1 times 2 times 74.55. Close. Divided by, open. 122.55 times 2 times 1, close, equals. It's a lot of button pressing, but you end up with this answer. Round this answer to the hundredths place, 15.21. And what is your unit and what is your substance? The same question I've been asking you in other videos. It's whatever your top right work is. Grams, KCL. That is a gram to gram or mass to mass problem. Go back through this video, watch it carefully, watch the other videos. Everything is done the same way. If you notice that you are in grams of one substance and going from grams to grams, these steps are required. It's the same thing. Start, molar mass, mole ratio, molar mass. Look at this question. How many grams of hydrogen are necessary to complete with this many grams of this? Well, there's your start. You're going to grams of hydrogen. It's going to have 4 steps. The steps are going to be the same. The numbers in the substance changes. So that is mass to mass or gram to gram. Do not forget, use your flow chart whenever you can. Going from mass of one substance, hopping over, going back. You are now masters of this. Yay!